everyone, welcome to my channel. In today's video we will learn about the structure of allene. So what is allene? The chemical formula of allene is C3H4 and the structure is CCC. These are attached through pi bonds and these are hydrogens. 4 hydrogens are attached. Okay, we will number the carbons as C1, C2 and C3. Now we will see that why in the allene structure these two bonds are in the plane of the paper. These two are in the plane of the paper. And these two hydrogens are perpendicular to the plane of the paper. This is the dash bond, which means the bond is away from the viewer. And this is wedge bond. That means it is towards the viewer. Okay, so what is the reason behind this? For this to know, we will consider an axis, and in this axis, this is the x-axis, this is the y-axis, this is the z-axis. We have assumed the axis to be like this. In this, what happens? We have considered the xy axis to be the plane of the paper and the z-axis to be the perpendicular axis from the plane of the paper. Okay. So now we will see the C1 carbon. In this carbon there are, as you can see, there are 3 sigma bonds, 1, 2 and 3. There are 3 sigma bonds and 1 pi bond. So what will be the hybridization? The hybridization will be sp2, where 1 s orbital is involved and 2 p orbitals are involved. So now we have to know which 2 p orbitals will be involved in the hybridization of this C1 carbon. The 2 p orbitals will be px and py. Since we have considered that these two hydrogens are in the plane of the paper and the xy axis are in the plane of the paper, so px and py orbitals will be involved in the hybridization of the C1 carbon for the sigma bond formations. Fine. So in this, px and py orbitals are involved in the sigma bonding. Now there is another bond here. This is the pi bond. So which p orbital is now left behind? Of course it is pz orbital. So now pz orbital will undergo pi bonding with the pz orbital of the C2 carbon. We have to know that px orbital will do pi bonding with px orbital, py orbital will do pi bonding with py orbital, and pz orbital will do pi bonding with pz orbital. So now what happens is that pz orbital will be doing pi bonding and connect C1 and C2. C1 and C2 will do pi bonding with the pz orbitals. Okay, so now we will come to C2 carbon. So now we will see the C2 carbon. In the C2 carbon, you can see that there are 2 sigma bonds and 2 pi bonds. So there are 2 sigma bonds plus 2 pi bonds. 2 sigma bonds means the hybridization is sp. Now we have to see which p orbital is involved in this hybridization. We already have seen that C2 carbon has utilized its pz orbital with pi bonding formation with the C1 carbon. So now we can't consider pz orbital anymore. So we are left behind with px and py now for the hybridization to be considered. Now see, we have taken this axis as x-axis, right? And the bond is also in x direction. So definitely we will be using px orbital for the hybridization. So px orbital will be involved in the hybridization of the C2. It will be involved in the sp hybridization and will form sigma bond. So now the C2 carbon has utilized its pz orbital and px orbital. Now which orbital is left behind? It's py orbital. Now py orbital is left behind. So py orbital will do pi bonding with the C3 carbon. The py orbital of the C2 carbon will do pi bonding with the py orbital of the C3 carbon. Coming to the C3 carbon. Now coming to the C3 carbon. In the C3 carbon you can see that there are 3 sigma bonds and 1 pi bond. So there are 3 sigma bonds plus 1 pi bond. So it is sp2 hybridized. Now which 2 p orbitals will be involved? See, in this what happens, we have already utilized py orbital in the pi bonding with the C2 carbon. Now which 2 p orbitals are left behind? It is px and pz. So px and pz will be involved in the sigma bonding formation in the C3 carbon. Therefore the hydrogens, the bonding nature of the CH here are away from the plane of the paper and towards the plane of the paper, or you can say away from the viewer towards the viewer. See, this plane is this one. This is the xy plane, since px and py orbitals are involved, so this is the xy plane. But here what happens in the hybridization, in the sigma bonding, px and pz orbitals are involved. So px and pz orbitals are in this plane. Hence these 2 bonds will be in this plane. So the bonds will be like this. But these 2 bonds are in this plane. So in conclusion, we know that the carbon, the p orbitals are like this. Here pz orbital is involved, so pz orbital is like this. This one is another carbon. These are the pz orbitals. They are forming pi bonds. And here py orbital is forming pi bond. This one is pz, this one is p1. Now we will see the 3D representation of Allene structure to understand it more better. You can see that these two hydrogens, this is carbon, this is hydrogen, and this is another hydrogen. In this, what happens is that this this bond and this bond, we have taken this as xy plane. These two bonds are in xy plane, we have considered that, right? See here, this one is pz, this one is pz, this one is pz, and this carbon is doing pi bonding now with py. This one is py, this one is py. Now these two are in the xz plane. This carbon using its p orbital, py orbital in pi bonding, so px and pz bond are left behind for sigma bonding. So this one is in the this one is in the xz plane, this sigma bonding, okay, and this one is in the xy plane. So I hope this is clear now. Thank you for watching. If you like my video, please like, share and subscribe.